Hi, welcome to part 2 of the video. We will now be learning about the starting materials needed to prepare the salts. Now let's take a look at our first example. If I want to prepare sodium chloride. Now sodium chloride is a soluble spar salt, so we have to prepare sodium chloride using titration. Now in order to prepare any salt by using titration, the starting materials that we will require is an acid and an alkali, or an acid plus a soluble carbonate. So which acid should we use? Which alkali should we use? So if it is sodium chloride, let's take a look at the acid first. The acid that we'll be using to prepare sodium chloride must contain chloride ions. So there's only one acid that has chloride ions, and that would be hydrochloric acid. So the acid that we use must be dilute hydrochloric acid. So hydrochloric acid gives us chloride ions. Now we need another starting material that will be able to give us sodium ions. So this must come from our alkali or the carbonate that we are reacting with the acid. So my alkali must therefore be sodium hydroxide solution. My carbonate must be sodium carbonate solutions. So let's take a look at the equations. If I have an acid plus an alkali, I'll get salt and water. If I have acid plus soluble carbonate, I'll get salt, water, and carbon dioxide. So if I have hydrochloric acid plus sodium hydroxide, I'll end up with salt, sodium chloride, which is the one that I want, and water. Or if I have hydrochloric acid reacting with sodium carbonate solution, I will get sodium chloride, which is what I want to prepare, plus water, plus carbon dioxide. Now let's try another example, lithium nitrate. So lithium nitrate is once again a salt that has to be prepared by using titration. So the acid that we're going to use in this case will be nitric acid, because nitric acid gives us nitrate ions. So the alkali must contain lithium ions, so I'll be using lithium hydroxide or lithium carbonate to react with nitric acid. As for potassium sulfate, I'll be using sulfuric acid as my acid. And for my alkali or carbonate containing potassium, I will be using either potassium hydroxide solution or potassium carbonate solution. So that's all for titration. Now let's take a look at add and access method. For add and access method, my starting materials, one of them has to be an acid. The other one can be either metal, base, or carbonate. So for zinc sulfate, the acid that we are going to use to react with our metal base or carbonate would be sulfuric acid, because sulfuric acid contains sulfate ions. Now my other substance, my other starting material must be able to provide us with zinc ions for my salt. So I can either use zinc, excess zinc, or excess zinc carbonate, or excess zinc oxide or zinc hydroxide. So recall bases are oxides or bases are metal oxides or metal hydroxides. So my equations are going to be as follows. If I'm reacting an acid with a metal, I'll get salt and hydrogen. If I'm reacting an acid with a base, I'll get salt and water. If I'm reacting acid with a carbonate, I'll get salt, water, and carbon dioxide. So if I'm reacting sulfuric acid with zinc, I will get zinc sulfate and hydrogen. If I react sulfuric acid with zinc oxide, I'll get zinc sulfate and water. Sorry, there's a typo here. It should be water. Or if I'm using sulfuric acid with zinc carbonate, I will get zinc sulfate, water, as well as carbon dioxide. Now, next example, copper 2 chloride. So copper 2 chloride is a soluble non-spar group 1 salt. So we'll be using add and access method. So one of my starting materials must be an acid. The other starting material must be excess metal, insoluble base, or insoluble carbonate. So I'll be using hydrochloric acid as my acid because of the chloride ions in my salt, copper 2 chloride. My other starting material must have copper ions. So I'll use either copper 2 oxide or copper 2 carbonate. Now I cannot use copper because copper is unreactive and will not react with an acid. I can use copper 2 hydroxide, that is fine, because copper 2 hydroxide is also an insoluble insoluble base. As for magnesium nitrate, similarly we have to use the add in excess method. So the acid that we will use is nitric acid. The other starting material can be either magnesium, can be magnesium oxide or magnesium hydroxide, or you can use magnesium carbonate as well. For bases, although we can use oxides or hydroxides, I have a slight preference towards oxides because all oxides are insoluble. So it makes it easier. I don't have to think about whether is it soluble or insoluble. Now the last method is actually my favorite. It is precipitation reaction. It is used to prepare insoluble salts, but in order to prepare this insoluble salt, we actually require two solutions, two soluble salts to give us our insoluble salt. And my two solutions, one of them must contain the cation, another one must contain the anion. So for instance, lead-2 chloride, I need two solutions. One of them must have lead-2 ions, another one must have chloride ions. So it'll be lead-2 blah blah blah, sub blah blah blah, chloride. Now, because I want both of them to be solutions, I have many different salts that I can use to prepare lead-2 chloride. But what do I like to use? Since I know that nitrate salts as well as spar salts, sodium, potassium, or ammonium salts are always soluble, I have a slight preference. I like to always use lead-2 nitrate and sodium chloride so that I can always ensure that they are solutions. So this is the equation. When I react lead-2 nitrate with sodium chloride, my ions actually exchange partners. So you notice how lead-2 chloride comes together to form a precipitate, my solid. My sodium ions and nitrate ions naturally group together to form a solution, sodium nitrate solution. So if I want the lead-2 chloride salt that's insoluble, I will just filter to obtain this solid because that's the only solid in my reaction. Now what about barium sulfate? So similarly, barium sulfate is an insoluble salt. I need to use precipitation. So one of my solution must contain barium ions, another one must contain sulfate ions. So because of my slight preference, I will use barium nitrate solution and sodium sulfate solution. But of course, you have more than one answer that can be accepted. You can of course also use barium chloride because all chlorides are soluble except lead-2 chloride and silver chloride. So barium chloride is actually a soluble salt. So I can also use barium chloride. I don't necessarily have to use barium nitrate solution. Similarly, sodium sulfate solution is not my only answer. I can also have potassium sulfate solution. I can have ammonium sulfate solution. I can have lithium sulfate solution. So there's many different answers available. Okay, so in summary, this is the flow chart. If a salt is soluble, you look at whether is it spar or non-spar or group 1 salt. Then you use different methods. If I'm using titration, I need an acid and alkali or an acid and soluble carbonate. If I'm using the add and excess method, I'll need acid plus excess metal, excess insoluble base, or excess insoluble carbonate. If it is a precipitation reaction, that's my favorite kind of reactions, I will just use two soluble solutions, one that has the cation, one that has the anion. So let's pause the video. Please try and do and identify the starting materials used to prepare the various salts. When you are done, unpause and check your answers. Okay, so these are the answers for the salts to be prepared. So please look for me if you have any other questions that you would like to ask. That's all. Bye-bye.